Welcome back, 5th grade. This is lesson 11.10. The title of lesson 11.10 is Problem Solving, Compare Volumes. Our question here is, how can you use the strategy make a table to compare different rectangular prisms with the same volume? So let's take a look at our first problem. Adam has 50 1-inch cubes. The cubes measure 1 inch on each edge. Adam wonders how many rectangular prisms, each with a different size base, that he could make with all of the 1-inch cubes. Use the graphic organizer below to help you solve the problem. So before we look at that graphic organizer, we need to take a look at what is this problem asking us. So we know here that Adam has 50 1-inch cubes. The cubes are 1 inch on each edge. And he wonders how many different rectangular prisms he can make with different size bases. So that's what we're going to have to look at. He has a total of 50 1-inch cubes, and he wants to make as many rectangular prisms he can, but they all are going to have a different base. Let's take a look at the graphic organizer so we can help ourselves solve this problem. So here, we need to figure out, well, what do I need to find? In our question, it told us we needed to find the number of rectangular prisms, each with a different size base, and that have a volume of a total of 50 cubic inches. What information do we need to use? We can use the formulas that we've been working with. So we know to find volume, it equals length times width times height. Or we could use our other one, volume equals base area times height, which is the same thing. And we need to use the factors of 50 because he has 50 1-inch cubes. So how are we going to actually use this information? This is a lot of numbers and a lot of different ideas, but how are we going to put this together to solve the problem? I will use the formula and the factors of 50 in a table. So we can make a table like you can see over here on the right that shows all of the possible combinations of dimensions with a volume of 50. Oops, that doesn't look like a 50. Let's erase that there. 50 cubic inches without repeating the dimensions of the bases. So that's really important. He wants each one to have a different base. So we can build this, and we're going to use this table over here to see what that looks like. If I have this base, what do I look like? If I have this base, what does that look like? All right, let's take a look at this table over here. So I can see that it has the base, the height, and the volume. So what we're going to be looking at is he wants to build, again, as many bases as he can with his 50 cubes. So when I have my base, I know, and I'm just going to erase this so I can see, that my base is my length times my width. Then we multiply it by the height. So starting off here, if I had a length of 1 and a width of 1, 1 times 1 equals 1. So then I think to myself, what times 1 equals 50? Remember, it always has to equal 50 over here. So in this case, 1 times 50 equals 50. So I can have a base of 1 times 1. Again, start off 1. If I do 1 for my length, 2 as my width, 1 times 2 equals 2. And I got to think to myself, well, I already found the length and the width, or I found that base area. And now I multiply it by my height. So what times 2 equals 50? Well, again, 2 times 25 equals 50. All right, why don't we skip down here to the bottom? So last one here. Again, if I have a length of 1, a width of 50, 1 times 50 equals 50. And I have to think to myself, 50 times what equals 50? and then the height can be 1. So it's a strategy, kind of like when we did our missing sides, to help us figure out. So now we've reached all the possibilities we could use with a length of 1. So now we're going to move a length of 2. So I'm going to do 2 times, and I have to think to myself kind of like what would make sense. Starting off a little bit smaller, we're going to do 2 times 5. 2 times 5 equals 10. And I think to myself again, 10 times what equals 50? I know that 10 times 5 equals 50. So my next base can be 2 by 5. And it'll give me a height of 5. 2 times 5 times 5. And that equals 50. Again, I'm going to do a 2. And moving up one more, 2 times 10. I'm going to go even a little bit higher, I think, than that. I'm going to do 2 times 25. I know that 2 times 25 equals 50. So again, what times what equals 50? 1. So I can have 2 times 25 times 1, length times width times height gives me a 50 again. Now I've kind of done all I can with a length of 2, so I'm going to move up to a length of 5. And I can do 5 times 5, which equals 25. Again, 25 times what equals 50? 25 times 2 equals 50. So I get 5 times 5 times 2, which equals 50. And moving on with 5 again, I can skip up 5 times 10. 5 times 10 equals 50. What times 50 equals 50? That's 1. So my length is 5, width is 10, height is 1. 5 times 10 times 1 equals 50. So now we've completed our chart. We've played around with different base areas in order to figure out how many he can make. So if you look on the bottom, it says, what else do you need to do to solve the problem? Well, we did fill in our chart. We did find a lot of different ways that we can solve this problem. But what we're looking for is, if we go back to the question, how many rectangular prisms with different size base he could make with the 1-inch cubes. Going from there, I have to count in this chart here, well, how many did he make? 1, 2, 3, 4, 5, 6, 7, 8, 9. So I know it's hard to see, and 10. So he made 10 rectangular prisms. Right? So using that strategy, building a chart and playing around with the base, we can use that to solve a lot of different problems. All right, class, we are now on to your practice problem for the night. So if you have your book, this is on page 694 if you want to use that. We're going to try this word problem. Mrs. Wilson is planning a rectangular flower box for her front window. She wants the flower box to hold exactly 16 cubic feet of soil. How many different flower boxes, all with whole number dimensions and different size base, will hold exactly 16 cubic feet of soil? Okay, so we're looking at the flower box, and she wants it to hold this certain amount of volume. Use the graphic organizer below to help you. So you can use this chart right here on your own paper, or you can use page 694. Just to give us some practice, I have to figure out my base. Remember making that chart. My height, my height. That's my height in feet. And then I have to figure out the volume. And that's in cubic feet. So that's going to help us figure out and give us a little help on that chart. As always, have a great night, and we will see you guys tomorrow.